Well, welcome back to Agree to Argue. And today we're going to be talking about, is the universe fine-tuned or a stroke of luck? And you know what? I found this so interesting in digging into this and how much agreement there actually is, but it kind of ends up being what came first, the chicken or the egg. Is the humanity here because we emerged because of the perfect fine-tuning, or is there perfect fine-tuning that was created by a mind for the purpose of humanity? And so I think that's what it all comes down to, is what's the point of it. And today we got all of our heavy hitters. We got Fuz Rana, and we have Steve McRae ready to bring it, and then our guest, astronomer Hugh Ross and Paul Davies. Super excited to have this. So why don't we jump in, since we're going to be talking about fine-tuning and getting into kind of the nuts and bolts of all of this. Hugh, why don't you introduce yourself real quickly and what you're bringing to the table today?
Yeah, well, I'm an astrophysicist, and got my PhD at the University of Toronto and did research on quasars and galaxies at Caltech. I presently serve as the president of Reasons to Believe. And like Paul, I've written several books on fine-tuning.
That was super brief. Wow, I'm impressed. You're saving it all for later, right? When you really bring it. And Paul, why don't you jump in and share a little bit about yourself with us and our audience?
First, let me say hello, everybody, and it's a pleasure to be here. I don't know how many of you are out there, but I hope it's a lot. So by profession, I'm a theoretical physicist. I often say I was born a physicist because from the earliest age, growing up in London, England, I was pretty obsessed with the idea of laws of nature and the wonderland above my head. And I went on to study theoretical physics, astrophysics, works for most of my career in cosmology, which is the large-scale structure of the universe. That was in London and in Cambridge. Then I went to Australia in 1990 and became interested in a subject now known as astrobiology, which basically is how did life begin, and is ET out there somewhere, being closely involved in that. And I moved to Arizona State University in 2006, where I diversified still further and have been running a cancer research program. So I'm trying to keep all these balls in the air at once. Interests are very broad, but running through it all is a real fascination with the foundational questions of science. And inevitably that gets into philosophy and even theology. And I enjoy conversations like this a lot.
And in your free time, you're also teaching, and you granted us this time graciously, and you're going to have to bounce a little bit early. So
that's right. I'm fortunate that I don't have to do a great deal of teaching, but such as I have to do starts right as this event ends.
And so I just want to remind everybody that is viewing that if you do have any questions that are pointed at Paul, please get your questions in early, and I'll make sure to get those before he has to leave us. But astrobiology, I think that's like the love child of Fuz and Hugh, like with his biochemistry, and Hugh with his astronomy. It's like there is all wrapped into one beautiful package. So what I wanted to start with is, Steve and Fuz, when we put our heads together and come up with ideas that we think not only would be interesting to our viewers, but have some impact and are consequential. You guys threw this idea out about fine-tuning and the significance of it. So I want to find out, like, Fuz, let's start with you, your perspective as to what's the point of the conversation? Why is this a significant dialogue to have?
Yeah. Well, from my perspective, I think one of the most provocative discoveries in science is the fact that the fundamental constants that define the universe have to assume exacting values. In some cases, that exactness is beyond perception. It's just an exquisite fine-tuning of the fundamental constants of nature, and it's an observation that I think demands an explanation. Unlike other scientific discoveries. And of course, when you start thinking about what types of explanations can account for that fine-tuning, you get into some very interesting metaphysical terrain and And I think if legitimately you could argue that fine tuning suggests that the universe actually is fit for a purpose. And if that's the case, then it must emanate from a mind. And so from a Christian worldview perspective, fine tuning is one of those features of the universe that really provides support for a theistic worldview.
Steve, I imagine you don't fully agree with Fuz, yet you thought that this was worthy of a conversation.
More than you think. Yeah,
I agree
with it more than you think. And not that I think that it demands a teleological explanation. I think that it demands an accounting for. It is a metaphysical question why we can apprehend the universe. This is something that man has always strived to put his place in the universe. And why are we here? Why are the conditions the way they are, that we have sentient beings that can look upon the universe and say, hey, look, we want to observe the universe. We want to understand the universe. We want to understand the laws of physics. Fuz takes it as, as some kind of design, as some kind of agent that had intentional states that designed the universe. I obviously, as a agnostic, do not believe that, but as I think that atheists take the not fine-tuning argument not seriously enough, because they too need to have an accounting. As Fuz said, that's the word to be used. What is the accounting for why we are here, and why these seemingly strange laws of physics that kind of make no sense if you really think about it, why things are the way they are, and why the numbers are the way they are, and why they have to be so specific for life to occur for us to exist.
So Hugh, with fine tuning, obviously most of us understand what that means, but it's like, I don't know if there's a difference in how you would define it and how Paul would define it, as far as like with astronomical fine tuning. What do you mean by that? Or from a Christian perspective, not just you, but from a Christian perspective.
Yeah, I think our generation tends to presume that fine-tuning and the anthropic principle is something that the astrophysicists invented in the late 20th century. But in fact, it dates all the way back to Socrates. This is something that humans have always been interested in, and recognize that this needs some kind of metaphysical answer. So it's not the new phenomena that you often see in the books. And I do appreciate that Paul's brought that out in some of his books, because it's so easy for us to kind of take on this hubris that, hey, we're the ones that came up with it, when in fact it's been around for a long, long time.
So when you say fine tuning though, Hugh, I've heard the term like Goldilocks, but that's like more about the planet. So are you saying, because I've heard you say something about if there was like a dime's width of more mass in the universe, it all wouldn't work. So are you saying that everything has to be exactly jot and tittle in the entire universe, how it is?
Well, it depends a bit on how you define the anthropic principle. I mean, what you see in some scientific papers is, okay, to what degree do we have to fine-tune the physics, fine-tune the different characteristics of the universe, our galaxy, and our planet to make possible the existence of a microbe? That's a little bit different than what's needed to make possible for the existence of human beings or the functional equivalent. And I think that's a big question. Does the evidence for fine-tuning increase as we go from, say, the simplest bacterium up to a simple animal, up to human beings, up to humans, where we have a high population and a high technology civilization? And
Paul, would you agree or disagree with that definition or that description of fine-tuning?
Well, let me, Jack, if I could just put my own spin. When I'm trying to talk about it, what does fine-tuning mean? We think of tuning a radio or something. And so let's go with that analogy. Imagine you didn't like the universe as it is. You wanted to change a few things, and you had like a designer machine in front of you with knobs on, and you can twiddle the knobs and change things. So twiddle this knob and you make all electrons a bit heavier. Twiddle that knob, you make gravity a bit stronger, and so on. Then physicists and cosmologists have sat down, worked out how many knobs on this machine. We call them undetermined parameters, but let's just call them knobs. And there's 30-something. And what you find, if you do the experiment, and I'm talking now about a mathematical experiment, not the real thing. We don't have this designer machine yet. But you can say, well, if all else is equal, we leave everything unchanged and say, make the weak nuclear force a bit weaker. Does it make any difference? And what you find is that for a lot of those knob settings, it doesn't make too much difference. But some of them seem to be very sensitive. And when we talk about fine-tuning, what we really mean is that if you had a value really not a lot different from what nature seems to have chosen, it would wreck the chances of any life in the universe. It would have literally lethal consequences as you twiddled those knobs on the machine. Now, the question, part of the problem of this analysis is that I don't think any scientist believes that all of these knobs really are equal. That is to say, we think the hope is, as physics becomes unified, that we'll find that if you lift the face off this machine inside, they're connected together. And the total number of parameters will be much smaller. And it's very easy to give examples, but I'm limited to 4 minutes, I know. But if you can ask me another question, you give us an example, and then I can tell you why tuning this knob may not be the right one to tune in a few years' time when we have a deeper theory. But that's the sort of general idea. And I don't think there's really any doubt about the fact that the universe does look like it's rigged in favor of life. And we do use the term Goldilocks for universes. I did, at least, in a book called The Goldilocks Enigma. And I'm referring to the whole universe and not just to our planet, which is a sort of separate set of issues. I'm going to stop talking there, otherwise I should get carried away.
Well, I'm just kind of curious, and this is a question for both Hugh and Paul. What would you say is the example of fine-tuning that maybe keeps you up at night, that is just so provocative? Now as a biochemist, I think that the fine-tuning of the nuclear or the resonance of the nuclear energy levels of beryllium and carbon and oxygen is remarkable, because the implications, of course, is that it leads to a universe where carbon and oxygen are in high abundance. And as a life scientist, that's really very important. And that, to me, that's the fine-tuning example that really keeps me up at night. I'm just curious, Paul and Hugh, what would be that one example that you think is real provocative?
Well, it's hard to pick one example. I mean, what keeps me up at night is the recognition. You need the entire universe, as massive, as old, as vast as it is, just to get one body on which human beings or the functional equivalent can exist. But to be honest, I think what really keeps me up is just looking at the Earth, Moon, Sun system, and maybe the planets that go with it, and just realizing, that's where you really see extraordinary fine-tuning. And what does all this imply?
So if I could just answer that question, because I always feel I should pay lip service to Fred Hoyle for the simple reason he gave me my first job in Cambridge decades ago. And it was he who drew attention to this so-called carbon resonance. He worked along with others in the 1950s on where did the elements come from, the chemical elements. If the Big Bang coughed out hydrogen and helium, what about all the rest? And what about carbon, the life-giving element? And there's no simple reaction, fusion reaction, whereby two nuclei that are lighter than carbon can collide and form carbon. And Fred reckoned that there must be a coincidence in the arrangement of the energy levels of these nuclei, so that when 3 helium nuclei came together, there was what is called a resonance. It's an enhanced reaction that would have produced that carbon. And he was sort of laughed at the time, but sure enough, he was right. And so he was much struck by the fact that if the nuclear force were slightly different from what it is, there would be no carbon and no life and no Fred Hoyle. So that's the famous one, and it's reappeared again and again over the years. I'm probably slightly more struck by the fact that the universe as a whole does seem to have an astonishing degree of uniformity, but it's not quite perfectly uniform. This is something I worked on myself many years ago, that it was born in a state of extraordinary smoothness, but with a tiny, tiny departure from that, which is enough to explain the emergence of the large-scale structure, the galaxies, and then the stars, and eventually the planets, and so on, without which, of course, we couldn't be here. So things were set up in this way where the interplay between quantum mechanics and gravitation was just such as to give this happy arrangement of things. Now, there are attempts to explain this in terms of what's called the inflationary universe scenario and quantum effects around that. And that's all great. I follow it very carefully. I contributed to it and I follow it with fascination. But I'm not totally sold on the idea that is what has happened. So it looks like the universe was set up initially in a rather special state.
And Paul, if I understood you correctly, a little bit back, it sounded like you said it's more important for some things to be fine-tuned and
yes.
than it is for others,
yes.
and that it's not mandatory for all of it to be finely tuned. Hugh, are you in agreement with that?
Yes, I am. I mean, the degree of fine tuning you see in the different parameters, whether you're talking about the universe or galaxy, our planetary system, yeah, they're different. Some are highly fine tuned, some are just not so much fine tuned. But what fascinates me is whatever parameter you look at, you find some degree of fine tuning that's needed to explain our existence.
Of course, we don't know, as I said earlier, whether some of these quantities which don't seem to be terribly important might eventually become tied via a better theory to some of the quantities which are more important for fine-tuning. We don't know what the final set will be. And there's a whole group, about a third of theoretical physicists, a big chunk, believe that we shall have one day a final theory in which there will be no free parameters. Everything will be nailed down, that all of these numbers we're talking about will come out of the theory, nothing left to explain. So that's a different way of looking at it.
So let me ask you a question, if I may, Paul, because I'm a biochemist, but I do a little bit of reading in theoretical physics, which is a very toxic cocktail, potentially, at least intellectually speaking. But do you believe that the constants of physics are actually constants, or do you think that they were shaped through the process of inflation? So
yes, the whole lecture on this. Well, a good friend of mine thinks that there's good evidence that even on the timescales that we can inspect, that is over billions of years, he thinks that there's evidence for slight changes in one of these constants called the fine structure constant. It's the strength with which electrons couple to light. I'm not 100% sure that evidence is good, but we've sort of dodged around the issue. But the prevailing view now among most of my cosmology colleagues is there's not just one universe, one Big Bang, that there were bangs scattered throughout space and time, and that as the universe, our universe, cooled from its ultra-hot, ultra-dense primordial state, that many of these numbers we've been talking about, even the laws themselves, sort of congealed out a little bit like what happens when water freezes to ice. You get all sorts of, imagine an ice flow in the Arctic or something, all sorts of complicated shapes. And you say, well, why is it that shape? And why is that iceberg that big? And so on. And the answer is, well, it's just happenstance. And so there's a point of view that although these numbers might be, and probably are, constant eventually, that in the turmoil of the Big Bang, it was all up for grabs. And so it all has to do with the way the universe cooled. I mean, literally the way the cosmic cookie crumbled.
So this is kind of touching into the multiverse idea, is it not? Or am I correct in that?
That's right. So if what we're saying is that the numbers that these parameters have, the ones we observe, are just accidents of cooling, and we could go into more technical details about symmetry breaking and so on. Don't really need to do that. The whole idea is that it sort of fell out in that particular pattern. But if you do another bang, it may fall out in a different pattern and so on. And then if you do this an infinite number of times, of course, you're assured that somewhere in that collection is going to be a happy universe in which the numbers come out just right, the Goldilocks universe. And here we are. It's no surprise we're living in a universe that supports life. We couldn't obviously live in a bio-hostile universe. So it becomes a selection effect. And then so if you don't want design, if you don't want to have a god or an agent or any, we don't even have to use those terms, but any element of teleology or preordained design, don't want that, then the alternative is to go, or one alternative is to go for this, vast array of a smorgasbord of universes, of which we're obviously living in a palatable one.
So I mean, how would you test for a multiverse idea? Because to me, as a Christian theist who's again enamored with fine tuning, it seems to me that the multiverse idea is on par with appealing to a transcendent personal creator. I mean, you really are pushing, in my perspective, you're pushing on the boundaries of what truly is scientific or a scientific idea. If the idea isn't testable, the difference really between the multiverse and appealing to a transcendent creator would be, one is providing a materialistic explanation, where the other explanation is appealing to the work of a mind. So how would you react to that comment?
Well, you don't have to be a Christian to say that this multiverse idea is unscientific. And I mentioned these people who want a final unified theory, and a lot of these people are string theorists, and we could get into that if you wanted. But they would say, no, we don't need a multiverse, and we don't need a designer. We just need this final theory that would explain everything. I think that's flawed for a number of reasons, which we could get into. But coming back to this very interesting challenge that I've put out many years ago, if there are any theologians who are good at mathematics and want to take on this challenge, there's an old, rather tired argument about is it simpler to believe that there's just a universe, or to believe that there is an agent or a mind or a god behind the universe who created it with all the complexity it has. And Richard Dawkins, for example, has sometimes said, well, the creator would have to be even more complex than the creature. So you're not simplifying things, you're making it more and more complex. So then is a multiverse more complex than a god? Now, you could quantify this. There's something called algorithmic information theory, where you can actually say how much complexity, as defined by this algorithmic information theory, how much complexity is there in your explanation. And so you take a particular model of God, pick your favorite one, and a particular multiverse model, and you could try and work through the mathematics and say, well, actually, the multiverse turns out to be simpler, or the agent turns out to be simpler. You could actually settle that argument using mathematics, but it needs somebody who is conversant with the mathematics and the theology to be able to carry that out.
Hugh has been fairly silent on this, and there was
do it.
There was so much common ground on this that I knew we were going to part ways here eventually. And Hugh, what are your thoughts on this? Because I kind of lean toward Fuz, and no disrespect, Paul, but it's the kind of the God of the gaps. It's the multiverse of the gaps, if you will. That it was inevitable. Hugh, what do you know about multiverse, and what are your thoughts on that?
Well, it's not just Christians. A number of non-theists have argued that the multiverse is not a good way to go. I mean, Leonard Susskind, for example, has pointed out that we agnostics and atheists have got to stop using that argument, because we're trying to use it to explain why there's no mind behind the universe. But if we take it to its logical conclusion, it basically says that we have no mind either. So you could literally use the multiverse to explain away all the research papers that every scientist has ever published without invoking any actual scientists producing those papers. So he says, we got to stop using this as a bad philosophical argument. And once again, I think we need to give credit to history. It wasn't just Leonard Susskind who pointed this out. Philosophers centuries before us pointed out the fact that appealing to an infinity really is not an appropriate philosophical way to go. And in terms of trying to appeal to some grand unified field theory to kind of explain away the design, What I have been able to do mathematically, Paul, is actually look at these different avenues where we try to say, well, let's see if we can condense this design into one parameter. What you discover is you're simply moving furniture. Yes, you can reduce the fine tuning of one parameter, but you wind up boosting it up in another parameter. You might be able to reduce it in 4 parameters and put it into one, but the fine tuning you have in the one is either equal or greater to the fine tuning you had in the 4. And so just recognize this furniture moving that often goes on unnoticed. And I think that's why we have to involve scientists and other disciplines, because often what we're doing is we're moving the fine tuning out of astronomy and physics into another discipline, and people in that discipline are saying, hey, wait a minute. Yeah, you moved the fine tuning out of your discipline, but now you've dumped it on us. And so we actually need to do an integrated scientific analysis of this to see what's really going on.
One of the problems that I have with the multiverse is that you can't just wave your hands and say, let there be a multiverse. You need some sort of model for that. And we actually have a model which is very favored. It's the eternal inflation model of Andre Linde. And this is a natural way that universes can sort of pop into being through a quantum tunneling process in this large inflating superstructure. And a lot of people think that this is an excellent model. But the thing is that to get that model to work, you have to have a universe creating mechanism. That mechanism is basically quantum mechanics. You have to have general relativity to describe the space-time. So you've still got a lot of ingredients. It's still a law-like system. And so what you've done is you've shifted the problem from the extraordinary features of this universe to the rather extraordinary features of the multiverse. So you don't explain everything. It's eternal inflation. So like the old steady state theory of Fred Hoyle, has no beginning and no end. So our universe has a beginning, a middle, and maybe an end. But the eternal system, the superstructure or multiverse itself, has no beginning or end. But of course, you don't explain something just by saying it was always there. You still need to ask, why does it have the features it does? Why that multiverse with those meta laws that operate and enable universes to come into existence? So for me, I'm perhaps less worried these days about the fine-tuning issue. I'm more interested in why there are laws in the first place. Why is it that compact mathematical relationships capture the nature of reality? And even more astonishing, why is it that there exist beings, namely ourselves, and maybe others, who can come to understand this, that can not only observe the universe, but can grasp what is going on? That is, that they're not just part of the cast, that they can see the plot of the play. And that I think is really tremendously significant. And when people say about anthropic selection in the multiverse, they're only concerned about that we observe a universe consistent with life, but we understand it. That goes beyond mere observation. That, for me, is the real challenge, to explain, as Einstein said, the most incomprehensible thing about the universe is that it is comprehensible. And that's what I tend to zero in on.
Yeah, this whole idea that, physics and chemistry explains everything, as philosophers would jump into this and say, well, wait a minute, aren't we human beings more than just physics and chemistry? The fact that we have a mind, the fact that we're able to emotionally react, the fact that we're able to speculate about questions, is there a God behind the universe? This seems to be more than just pure physics and chemistry. So I think we have to not only involve scientists from different disciplines, but we need to bring in people of a philosophical and metaphysical bent to actually challenge us and say, can you physicists really do explain everything from just pure physics and chemistry?
Right. So, and I agree with you entirely. And so we're into the old problem of reductionism, and that human beings are nothing but moving mounds of molecules, which I myself don't believe. So I've always taken life seriously and mind seriously. But many of my colleagues simply say, well, this is just a convenient way of labeling certain systems, and has no fundamental significance. So what we're really into is ultimate explanations. If we're trying to grasp what lies at the foundation of the order that we see in the universe, is it the laws of physics, or are there foundational laws or principles that emerge at higher levels of complexity, for example, like in living matter? And I've come around to the point of view that there are fundamental laws that operate in living matter that are consistent with but not reducible to the laws of physics. I've slowly built up that intuition over my career. Many of my colleagues still vehemently disagree, but I think we have to take that seriously.
Well, I find it interesting. Now, go ahead.
This is Steve. This is kind of what you were saying and intimating earlier, is that about the metaphysical, that the non-theist community really needs to answer for the laws, and even the Paul, you and I, when we had a correspondence earlier about our humanity's even awareness of the laws. But Steve, isn't this kind of what the whole point you were saying? Like, there needs to be some sort of response to this.
Yeah, it's exactly what it is. I mean, Paul notes that, even if we can apprehend the physics of our own universe, the physics of a meta universe, the metaphysics that would be applicable to why we have this particular universe and all the other level 2 universes out there, because I would imagine that most level 1 universes probably have similar type of characteristics. But if there are other universes out there that are very different from ours, it still seems to raise a question that we have some kind of cosmic lottery, that we have got the one that, if it was the case where at the initial conditions in the universe where things were being solidified, and after we got out of the Planck energy range, things were like, these are the constants that we're going to have here, that we develop light from that, because that's something that I think not just atheists but theists have to account for. And my question to Dr. Ross would be something along the lines of, if God is this omniscient and omnipotent being that can create life any way he wanted, why would he even worry about having this particular universe fine-tuned in any way whatsoever? Because he could have done it any way he wanted. He could have made the weak force differently. He could have made the fine structure constant differently. He could have made the speed of light, anything he wanted. What would be the reason why he created it exactly the way we find the fundamental constants to be as they are?
Well, it's not correct that the Christian worldview is that God designed the universe for this one and only possible life. After all, the Christian faith is founded on the fact that God created at least 2 distinct species of intelligent life, human beings and angels. And according to the Christian faith, angels dwell in a completely different realm than we do, different dimensions, let alone different physics. So yes, God's got options. He's demonstrated he's got those different options from a Christian worldview perspective. The Bible ends with God saying he's going to create a brand new realm, and even describes what the physics is going to be like in that new realm and the dimensions. So yes, he's not locked in to the physics of this universe. He's not locked into beings just like us. He's got multiple options.
But he did create this, he actualized this particular world, this universe, such that it is, right? I mean, so if he actualized it the way such that it is there any reason why he didn't do it any bit differently? Does he just randomly pick this one? Or was it arbitrary, or was he beholden to some kind of metaphysics, or meta, as a case would be, metaphysical laws, especially, that would be somehow applicable to this particular universe?
Well, Steve, I addressed that question in a book called Why the Universe is the Way It Is, and making the point that from a Christian worldview perspective, we can identify at least 12 independent purposes or reasons for why God made the universe the way he did. And given that you've got these 12 very distinct purposes, and there may be a whole lot more that haven't been revealed to us, we would expect that there would be design trade-offs. And just like when you're trying to make an automobile, there will be inevitable design trade-offs. In fact, I would argue that the search for design trade-offs is one way to put the anthropic principle to the test. I mean, there could be other fine-tuned characteristics we're not even aware of yet. And one way to look at that is, let's look at the fine-tuned characteristics we're aware of already and see if they depart slightly from optimality. If they depart slightly from optimality, and if that slight departure is the intent of a mindful creator, we would expect that we're going to discover a design trade-off. In other words, there's more fine-tuned features that we haven't yet discovered. And there's been a number of astrophysicists, for example, who've actually used that principle to try to discover more features. I mean, a good example of that would be David Waltham in Britain, who's basically looked at the moon, for example, and said, you know, we've always looked at the mass of the moon as being fine-tuned to maintain the stability of our rotation axis. But the truth is, it's not optimal. It's tilted way over to the heavy end of the moon's mass. And he used that as a line of research to say there must be another reason why it's slightly off optimal. And indeed, he was able to publish a couple of papers making the point, hey, there is really something here. And what I like about his research is basically showing us that the anthropic principle, the principle of fine-tuning, is a useful tool to advance scientific research.
Paul, you're the one that brought up the laws. Do you perceive them as actual laws, or that they just look like laws, or what is your perception?
Yes, well, that's of course a very important question, because there's a school of thought that these things we call laws, which are celebrated by theoretical physicists, are just inventions of a small self-serving community. They don't really exist. That we say, well, we are really successful in explaining the world with these laws. And the retort is, well, you would say that, wouldn't you? Because you need to get funding. That's a very cynical view. I personally believe that the laws are real. They're really out there. That when I say that gravity gets weaker as you move away from the sun, like the inverse square of the distance, I think that is a real effect. I think it was true before there were humans and will be true after there are humans. So I think they're out there. And the question is really, in my mind, is whether these laws somehow transcend the universe that they apply to. And there's a big division in the physics community. You won't get agreement on this, because some say, well, particularly if you're involved in more sort of practical research, designing a better superconductor or something, that the laws are sort of useful ways of organizing our knowledge and being able to use mathematics to make predictions and so on, but that's it. That's sort of practical tool, versus the sort of dreamy theoretical physicists that I hang out with, who think, well, you know, the laws are the bedrock of reality, that in the beginning there were the laws, you know, that these laws somehow underpin all of the universe, and that in particular, we're going to get into the subject, if there isn't a multiverse, if there's just one universe and it came into existence in this Big Bang, can the laws explain how the universe originated in the Big Bang? Can we appeal to those laws to say that the universe could have come from nothing, that is, from a state with no space, no time, and so on? Well, if you want to do that, then these laws have to be outside, they have to transcend the physical universe. And of course, just in the way that in classical Christian theology, God transcends space-time, God transcends the physical universe. So the laws take on this sort of theological aspect. There's no secret about that. That of course, the idea of these eternal, immutable laws emerged in Europe in the 17th century, that under the influence of Greek philosophy and monotheism. And so we see that reflected. But you don't have to have that. We could have a possibility where the laws themselves are either not infinitely precise mathematical relationships, but something either more flexible or more fuzzy, or that the laws somehow emerge as the universe cools. And the great architect of quantum gravity, which underpins so much of what we've been talking about, John Wheeler, his favorite dictum was, there is no law except the law that there is no law. And I believe that we can go quite fruitfully down that path. There are many of my colleagues now who are interested in this idea that maybe simply this old idea of invoking laws to organize our understanding of the universe is sort of passé. We've got to go on to some different conceptual model. We're having a workshop on it next month in the Beyond Center at Arizona State University.
They're not laws, there's guidelines. There's guidelines for the universe.
It seems to me, if I could just jump in here real quick, that it's very difficult to escape the idea that regardless of how you conceive the beginning of the universe, that you can't escape the necessity of an uncaused cause, right? And it seems to me that, and this is just my speculation here, but it seems to me that Christian theism is a little bit more satisfying as an explanation for an uncaused cause. To me, it makes more sense to think that there is a being that is eternally existing that then conceives of the laws, that may be transcendent, or conceives of a universe, whether it's a multiverse or just a true universe that he has brought into existence, versus that there's these mechanisms or these laws that are uncaused. It seems like from a naturalistic perspective, that just isn't very satisfying. I don't know.
I take you to task on your terminology because I think it causes a lot of confusion. The word cause, in common parlance, cause and effect, implies the existence of a sort of temporal sequence. The cause happens before the effect. But if what we're talking about is the origin of the universe being the origin of space and time, the idea of talking about the cause of the universe goes away. The universe, if we go back to the Big Bang and then time doesn't exist before that, it's like, as Stephen Hawking said, it's like asking what lies north of the North Pole. When you say what lies before the Big Bang, say, well, God lies before the Big Bang. It's meaningless if there was no before. But I'm not trying to duck out of this, because you can still say, well, what is the explanation for the Big Bang? So we don't use the word cause, but explanation. You can still ask for that. Now, a physicist might well say, well, that explanation is the laws of physics. So what are the explanation for the laws of physics? If you like, where do they come from? But what is that explanation? Now, where theology has got a bit ahead of science, I think, in dealing with this question, and scientists may have something to learn, is the theological concept of a necessary being, a being whose non-existence is a logical impossibility. So this doesn't come down to something empirical. The question is, can you actually use the foundations of logic itself? Can we use reasoning to argue that there must necessarily exist something? This something doesn't have to be anything remotely like, the God of the Bible or anything like that. But is it possible in this tower of turtles, is the analogy we often use? It's not an infinite tower of turtles. It's not turtles all the way down. There's a levitating super turtle somewhere down there that supports, you might say supports the laws that bring the universe into being, living creatures and so on. Or this super turtle might be, something like a god. But whatever it is this a fruitful line of inquiry? I don't find many modern theologians actually take terribly seriously the notion of a necessary being, the ontological argument for the existence of God. But it was a heroic attempt to really say, otherwise you just push it back, and you say, well, my laws of physics are better than your God or something. And someone else will say, well, plague on both your houses. We should come up with a better idea than either of these. And is it just going to peter out, or do we revisit this notion that there can be something necessarily holding up this explanatory chain?
So you're okay with the universe being acausal?
Being acausal?
Without causation?
Well, I don't like the word cause. Yeah, yes, because in quantum mechanics, so classic example, a chunk of uranium, half-life of 4.5 billion years. And so you watch it, Geiger counter, click, click, click. That atom decayed at 3 o'clock on a Monday afternoon. Why did it pick that time? What caused it to go then? The answer is there is no cause. In quantum mechanics, there's genuine spontaneity, genuine indeterminism. And if you appeal to quantum physics to make the Big Bang go bang, popped into being in accordance with the laws of quantum physics, and that was the basic idea of Jim Hartle and Stephen Hawking in their quantum cosmology, that explained the origin of the universe. It doesn't need anything else, but you do need the laws of quantum mechanics to somehow be there. And so we should really be, not trying to get into this trap. So many people get into what made the Big Bang go bang, what caused it, what was there before it. At endless dinner parties where you go down that fruitless line of conversation and you say, well, there was no in a simple model, there was no time before the Big Bang. And they say, I don't understand what that means. Well, you haven't read your Augustine. The world was made with time and not in time. It's an old idea.
Hugh,
well, I'm talking too much.
No, you're great, Paul.
I love that. So, as somebody who has a small background in reactor physics, everything you said I couldn't agree more with.
Hugh, what I want to touch on that Paul mentioned is about the laws, and I find it fascinating that, Paul, from your perspective, you're stating clearly that you believe that the laws have to transcend our universe. But Paul, you made a statement that perhaps the laws emerged after the Big Bang. And Hugh,
right.
This is what I wanted to direct to you. I am very late level at this, but order emerging from disorder, that doesn't seem to fit right to me with like the second law of thermodynamics. And what are your thoughts on the transcendent nature of it, of the laws, and about the potential of them emerging from the Big Bang?
Well, to get at the transcendence issue, there's this idea that if you don't have time, nothing can happen. And yet what we see both in the Bible and the space-time theorems, there's an actual beginning to time. Time doesn't exist until the universe exists. And yet what we see in the Christian worldview, it's in the Bible, God is experiencing temporal phenomena before he creates cosmic time. So who says that temporality has to be limited to a single dimension of time? It seems like from both the Bible's standpoint and the space-time theorems, there's an entity out there with the power to create dimensions. And maybe those dimensions are not just limited to space-time dimensions. And then we get at the laws of physics. I have a number of books in my library written by non-theistic physicists who are trying to claim that the laws of physics created us. The laws of physics created everything. But now you're appealing to entities that have no personality, that have no mind, that have no demonstrated creative power, and you're trying to claim that's the answer to everything. So I think Paul is right. We do have the question, where did those laws come from? And when did they come into effect? And is it possible you could have different laws of physics in a different realm? Which again, I think is perfectly consistent with a Christian worldview that yes, there would be a different set of physical laws and dimensions to describe, for example, the angelic realm. The other thing I would add is the problem of free will. You know, a number of books I have here in my library written by non-theistic physicists basically admit the biggest challenge to their atheistic worldview is trying to explain how pure physics and pure chemistry can explain the operation of human free will. And this again gets at the question, is there more to reality than just physics and chemistry?
Well, and that's, Paul, something that you had brought up too, free will and volition in general, right, Hugh?
Right.
Self-awareness. And Paul, you had brought up the idea of these laws, but also that that we are aware of these laws. And,
right.
And on this planet, we are the only creatures that are aware of them. The lesser creatures.
Well, we're more than aware. We actually have come to understand what's going on. And the example that I just recently used with my students was when Newton saw the proverbial apple fall when he was sheltering during the pandemic in 1665, saw the apple fall and didn't just see a falling apple, but saw something connecting the motion of an object near the Earth's surface with the motion of the moon. Now, Newton's dog, Rover Newton, sitting beside, saw the same apple fall, so had the same experience, but didn't make that abstract connection about the mathematical underpinnings of what was being observed. And that, I think, is so important. It's not that we just notice regularities. People notice for thousands of years that the sun rises and all that sort of thing. But we stitched it all together and have used that to predict things that human beings would never, ever have dreamt existed and would never have discovered by any other mode of thought. For example, the Higgs boson. or neutrinos. Neutrinos are going through you as you're sitting there in their countless trillions every second. You don't feel them, don't worry about it, they don't do you any harm, but they are there. And you wouldn't notice it in daily life or even with some very, very careful observations. And yet, through understanding the underpinnings of these abstract mathematical laws that connect together all these disparate phenomena, it's possible to make the prediction that there are these particles, and sure enough, you can do experiments, and there are. So we have come to understand how the universe is put together in this very subtle and very beautiful way, involving these mathematical relationships. And we haven't completed that program yet, and it is never completable. It may be outside the scope of the human intellect. I don't know. I hope not, but we've done very, very well. And it just seems to me rather extraordinary that there is a planet that has beings on it who have, stumbled across this pathway to this deep grasp that I sometimes like to say, have decoded the cosmic code on which the universe runs. So I think that's something of enormous significance. I'm not sure that's free will, which is a long conversation about free will, but it has to do with consciousness and comprehension. And I think that's something that's often left out of these discussions.
We have a lot of questions to get to. Oh, Fuz.
Well, just a couple of unconnected thoughts, but maybe I'll just focus on one because we want to get to the questions. But I think to build off of a point you made, Paul, and a point that Hugh made, I think it's actually intriguing that Augustine, and this is a nod to my good friend Ken Samples, who loves Augustine, who's a bit of an Augustine scholar. But it's intriguing that by examining Scripture, Augustine develops this concept that time had a beginning. Because when you really start thinking about that idea of time having a beginning, it's a very bizarre concept in some respects that is totally counterintuitive to our experience as human beings, definitely for people that would have lived in a pre-scientific time. And so don't you find that intriguing that a Christian theologian centuries ago would pick up on an idea that really is only been recently demonstrated as plausible from a scientific perspective?
Well, Hugh may well have an answer to that. Sorry if I butted in, but I would just like to say I don't think it was that Augustine somehow had a foreknowledge of Einstein and the general theory of relativity. This wasn't a prophecy, but was a very shrewd answer to the problem about an eternal God. If God exists within time and has been sort of, as it were, sitting around forever and ever, why make a universe, just at this particular time, 13.8 billion years ago from now, rather than at some earlier time? Was it's a whimsical thing? If God is a perfect being, then we don't want then the idea of a God who didn't think of this before, or didn't seem a good idea till now. I mean, it just seems sort of ridiculous. And so it's a very good way, I think, of avoiding that problem.
But I'm under the impression, and Hugh, please jump in if you would like, that Augustine had the seeds of that idea from what we see in Scripture. So like the Apostle Paul is writing to the church at Corinth before time began, right? God is putting in place this plan of salvation. So I think Augustine may have been a brilliant scholar who saw this as a really shrewd maneuver to solve a theological problem, but I think he got the seeds of his idea from Scripture itself.
That's true, and he's not the only Christian theologian who looked at the Bible and saw those statements. I mean, that's something that theologians throughout the centuries have agreed upon, that the Bible is founded on the concept there's an actual beginning to the universe that includes the beginning of space and time itself, and that God was active before he created time.
So as we move into the Q&A, I do want to kind of wrap up some of the thoughts on the fine tuning and the laws. And Hugh, starting with you, it seems like you and Paul are in agreement about that there is fine tuning, that there are these laws, that Paul even says that he personally feels that they need to be transcendent. Where you both land, even though you're looking at the same evidence and very much in agreement, Hugh, your bread and butter and what you've done for decades now is you're saying that this all points to and necessitates a mind, an intention, a creator. And Paul, it sounds like you land like these are magnificent, and our universe and multiverse are magnificent, but it does not necessitate a mind. And so I just want you both to wrap up, beginning with you, Hugh, is why do you feel, looking at all of the same evidence as Paul, why do you feel that this necessitates a mind?
Yeah, I'm not sure that Paul and I are that far apart even on that issue. But, I've written for years that if we actually look at the multiple purposes that we see the fine tuning implying, number one, this can be a guide to future scientific research. I've been arguing that the anthropic principle has predictive power. I can think of at least a half dozen different ways that this fine tuning can be demonstrated to have predictive power. And my motivation in showing that predictive power, that scientific success, is basically to draw the scientific community to consider the metaphysical implications. I mean, if this really does have predictive power in multiple ways, with multiple concluding purposes, then this really does point to a mind that's got particular purposes for human beings. And if God indeed created the universe and created us human beings so we can fulfill specified purposes, I think it's crucial we discover what those purposes are. I mean, that's our destiny. And I think the anthropic principle can guide us towards discovering that purpose and that destiny. And that's something that the authors of the Bible have stated thousands of years ago. But to quote Feng Liji in China, he says, science has now advanced to the point that what was purely a theological issue is now an issue for theoretical and observational physics. So let's go for it.
And I don't know if we fully got into why it necessitates a mind, but Paul, since we only got 15 minutes left with you, why don't you just kind of fill us in on why you don't think it has to have a mind behind it and intelligence behind it. And then if you want, we'll jump into some Q&A before you leave us.
Yeah, of course. Well, the first thing is I should reiterate that I do take mind seriously. A lot of people say, well, look at consciousness. It'll go away when we understand it properly. It's all just molecules. So I do take mind seriously. And then the question is, is a sort of super mind that somehow made the universe as it is. And I've always had a natural antipathy to the answer, well, how do we explain this? How do we explain that? Well, God did it, end of conversation. So I never want there to be an end of conversation, because I want to ask, well, what about this God? And why is God the way God is? And all those sorts of problems you get into. And so I am a genuine agnostic, in the sense that agnostic even within science, that all these ideas I find sort of thrilling and interesting. I think probably at the end of the day, I feel historians will look back and say, well, they were having a sort of stupid argument with the wrong conceptual framework all along. They should have been asking this question and not that question, or they should have had this idea and not that idea. Imagine going back to talk to somebody at the time of Newton, in invoking quantum mechanics as an explanation for the decay of a nucleus. We don't know what you're talking about. We don't have those concepts. And so I find a lot of the discussion about, between science and religion very sterile for that reason. It sort of gets bogged down in these things. And I just feel that we need to, and I think we have here, elevated the discussion to a higher plane. So I take mind seriously, whether it's something that emerges later on in the sense of consciousness, free will, and so on, or whether it's somehow embedded in the nature of reality. I feel uneasy using a lot of these terms So what I tend to say is that I think when we look at the universe, there seems to be a scheme of things, a rational scheme that we can, at least in part, uncover through this wonderful thing we call science and mathematics. So it's the universe is not just a haphazard conjunction of odds and ends sort of thrown together. It is a coherent unity with an underlying scheme. Whether a scheme amounts to things like purpose or mind, these are all very difficult terms to deal with. And what I will sometimes say to people is we always take from daily life concepts and project it onto the universe. And one of these is mechanism. Human beings make machines. So is the universe a gigantic machine? I mean, that was very fashionable at the time of Newton. Now people say, the pinnacle of our technology are computers. So is the universe just a computer, gigantic computers? It's a nature as a computation. So what we're doing is we're projecting onto nature our human categories. Well, one of these human categories is being alive or being conscious and so on. And we talk about living organisms have purposes. So does the universe have a purpose? Well, I would say the universe isn't a machine, it isn't a computer, and it isn't a living organism. But it has some aspects of mechanism and computation and purpose. We see them reflected in nature, but we're really lacking a sort of grand unified theory of existence that would give context to the concepts that I just outlined.
As Hawking said, the theory of everything, right?
Well, yes, and in fact, when I quit this fascinating discussion, I'm going to be teaching a class on the theory of everything. Is this just a pipe dream? Can there be such a theory? What would it mean? And it wouldn't be everything, because it wouldn't tell you how you're going to vote in the next election or anything of that sort. But it might tie together these more profound things. Maybe if it exists, maybe it exists, but we will never be able to apprehend it.
We'll just tie into your feed of your class. We'll just keep this going. Paul, are you willing to field just a couple questions before?
I can hang in here for another 20 minutes.
Okay, wonderful. Well, then I might pepper some, for others as well. So it's not just all you. But the first one we do have for you, Paul, comes from Slam RN, and she wants to know, back in your reference to talking about the knobs and the dialing them in, she said, what knobs could one change and still have a universe that is life permitting? Can you name some?
Oh, yes. I was taken to task, incidentally, by my US editor, saying that in America, they don't know what you mean by knobs. They call them dials, so, if anyone's confused. I suppose a knob, you might have in a closet to open it, so it doesn't turn. So
good point.
Well, gravitation doesn't seem to be a very critical thing. If gravity was 10% stronger, it's unlikely it would lead to any effects. People have looked at stars and would they be brighter or something? And there may be effects, but not obviously lethal effects. And then there's some obscure parameters in particle physics, like the Weinberg angle and so on, that may not make too much of a difference. So I won't get into the technicalities of that.
And I have another question here from Christ Alone. It wasn't actually Christ Alone that posited this question, but someone named Christ Alone. Okay, so just so you know, you're not getting a question from Jesus, Paul. Okay. So this person is saying that you, Paul, mentioned Dawkins' statement that the creator would have to be more complex than his creation, paraphrasing. What's the logical basis for that statement? Imagine that you as a human being were to build something because you have an idea of it and you put it together. I don't think anyone would doubt that the designer would be a more complex entity than the thing that was designed. Now, when you take a Darwinian evolution, then what you find is a process, a long, complicated, expensive in energy and entropy terms process that generates the appearance of design in life. But if you say
what is Darwinian evolution, it's variation with selection and inheritance. So that set of concepts is much simpler than, a tiger or whatever might be the product of that. And so the power of Darwinian evolution is to explain complexity in terms of conceptual simplicity. I think people use these terms, as I said earlier. Some people say, well, God is simpler than the universe. I'm not sure how many theists would actually claim that. If you can demonstrate that it is simpler to have, a being with simple properties that would explain the complexity of the universe. But it seems very unlikely from the point of view of any sort of creative process that we know, other than Darwinian evolutionary process. But, these are obscure topics. I don't know many people who have really applied rigorous mathematical ideas like algorithmic complexity theory.
Would any of that have to do with information theory, as far as the maximum amount of information that the universe has, whether it's on some kind of cosmological boundary that for the holographic principle, that anything that beyond that would have to be more complex and be more able to have information beyond that?
It's really more the complexity of the explanation, not the complexity of the universe itself. So, just how complex, if you want to rate different explanations of things, you can do this in a manner that I described using algorithmic complexity theory. And then you can opt for basically the simplest explanation. That it's Occam's razor. It's a way of quantifying Occam's razor, which you could apply to some of these ideas. And I don't know anybody who's actually done it. Let me just say that there's some counterintuitive things. So, for example, if you take a crystal, that's a very simple thing, a crystal lattice, infinite crystal lattice, very, very simple type of structure. But now imagine that you remove from that crystal lattice a random subset of atoms. Then what you're left with is something random, and what you've got on the other side is something random. You've separated something simple into two very complex things. But you put them back together again and you've got simplicity. So if you look at any one of the things, it seems to be infinitely complex, but the two things together are simple. So intuition can lead you astray. The sum of two exceedingly complex things can actually be simple.
And Hugh, I just wanted to let you know, since you're also new to ATA, even though we're trying to keep this quick, that if Paul says, or anybody says anything that you think is of interest or you want to comment on or have a question,
or is really stupid,
yeah, feel free to jump in. We're just trying to keep it brief and quick, but I just wanted to make sure you don't feel like you just have to sit there and listen quietly. You can jump in.
I'll be gone soon.
Well, I also know we have Paul for a short period of time, so I want to make sure he does get every opportunity to say what he wants to say, because I'm going to be around.
Okay, thanks, Hugh. Well, you know what? I'm going to go ahead and peruse through the questions, but while I'm doing that, what I'm going to do is pitch one to you, Hugh. And this comes from Travis Lee. And Travis wants to know, does your version of the precision that increases for simple life to advanced life to a high-tech global civilization, does that bridge the gap to a personal God?
Well, it does in the sense that it shows you that there's more specified purposes involved. And, people push back on fine-tuning and the anthropic principle by saying it's a circular argument. And I think one way to counter that is to say, well, do we actually see a hierarchy of increasing highly specified purposes as we go, say, from what you need to get atoms to what you need to get a simple bacterium to what you need to get human beings with billions of people on one planet having high technology? And how does that tie into the laws of physics? Are the laws of physics themselves fine-tuned, not just to create a universe with life, but to fulfill specific purposes for human beings? I find it fascinating, for example, I think the greatest fine-tuning you see in the laws of physics is that they're fine-tuned to eradicate evil amongst the human species. And so this, again, is bringing together purposes that goes far beyond just the physics and chemistry, sustaining the worldview. There's more to life than just molecules and atoms.
Paul, you're sitting there well behaved too. Fuz and Steve, everyone is so well behaved today. I'm a little shocked, but that they're behaving themselves for you, Paul. They're trying to.
That's all because of you.
Well, like you said, we're not going anywhere. We have Paul here, and I'm just fascinated.
Hugh Fuz and I, we work together all the time, and Steve is like an old friend, and so everyone's being nice because we have company in the house. But
well, I mean, we accomplish nothing by being rude to each other.
Exactly.
There are far too many discussions in this subject area where it just becomes a slanging match, which the media can regard as entertaining, but it's not very informative. And I mean, if you want a clear point of disagreement, I've never been a great fan of angels, I have to say. That doesn't figure anywhere in my worldview. But I don't think it would be very productive to take that up with you.
No, this is fantastic. And I'm so glad, because you really get the spirit of the show, that this is, to dig into where we agree, where we disagree, and trying to get into the meat and potatoes of it. And we do have another question, and this one is question for the fine tuners. So actually that would be both Paul and Hugh. This comes from Leophilus. How can we determine that the universe is finely tuned if we do not have a statistical population from which to derive a probability for the universe we see?
Yeah,
Excellent.
That's a great. Yeah, go ahead, Paul.
Well, I was going to go ahead because you actually had to go with that earlier, Hugh, and I thought you raised a really interesting and important point there, and we never got a chance to discuss it. And that is, if your explanation is a statistical one, there's a large ensemble of universes, and we are just sort of we are typical human beings, then there'll be some parameter range. The fine-tuning is never such that it's absolutely zero. There's always a range of values of the parameters, and you might expect that our universe would occupy a typical point in that range, that we wouldn't be like sort of right on the edge of the range, that the universe just squeaked home with the emergence of life, somewhere in the middle. And Martin Rees has given a really nice analogy of this. It's not an analogy, it's an example, that planets move on ellipses, as I think everybody knows, but in the solar system, the Earth's orbit is actually nearly circular. We say that the eccentricity of the Earth's orbit is very low. And you might think, well, why is that? Well, if it were much greater than it is, then the climatic excursions would be rather terrible, and there probably wouldn't be beings like ourselves asking these sorts of questions. And so this is a good example of the anthropic selection effect. We couldn't live on a planet with a high eccentricity. But if we discovered that the Earth's orbit was circular to 1 part in a billion or something, well, that's far more than you would ever need to select it on anthropic grounds. And so you would seek for some law of nature or something. And so, as a matter of fact, in the Earth's orbit, it's sort of a very typical, not actually in the middle, but sort of not far from what would be a habitable window in that particular parameter. Now, you can apply that to these other examples we've been talking about, the carbon resonance, the large-scale structure of the universe, and so on, and say, statistically, are we in a typical region of that parameter? And there's been some attempt to do that. So that's future work. And you should find that as we learn more and more about how the universe works, we should find that the numbers drift more and more towards typicality within those parameter windows. So we still only have one sample, but if your explanation is there's an unseen ensemble and we are a typical member has selected this parameter value, then that's a weak way of testing the anthropic selection effect.
Hugh, I want to give you a chance to
yeah, I mean, a lot of the books I have in the anthropic principle, the whole focus is on the universe and the laws of physics, where I would agree we have a sample size of 1. There may be other universes, but we don't have the capacity to detect them. However, when we look at, say, stars, we got 50 billion trillion plus. And so we can say, is there something special or anthropic about our star, the sun, compared to all the other stars? Now we got a big statistical sample. You can do the same thing with our galaxy, with our planet, with our moon, with the system of asteroid and comet belts compared to what we see elsewhere. And I love your example about the eccentricity of Earth's orbit. It is very low, but if we're actually to apply the anthropic principle as a predictive tool, we could say, well, why doesn't it go down to zero? And that when we actually discover it, you run into problems if it's exactly zero. You run into problems if it's a little bit less than what it is. And so this actually gives us more insight into why the solar system looks the way it does, and begin to ask questions. What about the eccentricity of the other 7 planets? And we discover that there's anthropic fine-tuning in those as well that impacts our habitability of this planet, at least the habitability of humans. Because I would argue or agree, if we're talking just bacteria for a few months, then you can have a much broader range of eccentricities for Jupiter and Uranus and Neptune than we have if we're trying to make human civilization possible.
Paul, do you have time for one more, you think? One quick one?
Just one. Yes.
Just one. Nicholas Tan asks, is there anything other than positing a God or multiverse of the gaps? And since it was multiverse, I wanted to pitch it to you, that compels forces to be what they are.
There is a line of reasoning which I tried to articulate in my book. Here we are, go with the commercial. The Goldilocks Enigma, why is the universe just right for life? In which I took up Wheeler's set of ideas of the laws which are not sort of fixed and immutable, but are somehow tied to the existence of observers and mathematics and life and mind, and you get a sort of self-consistent, self-reinforcing type of explanation. I wanted to take it beyond what Wheeler had said originally. So you have to take teleology seriously. What's that? If I use that term among friends, they say we don't know what you're talking about. And it really means a sort of goal or a destiny. It ties what happens later to what happens earlier. And quantum mechanics, turns out, can do that. And Wheeler himself articulated, Einstein did actually, but Wheeler articulated through his so-called delayed choice experiment in quantum mechanics, the way in which the measurements we choose to make now affect the nature of reality as it was in the past, which is less than completely defined because of quantum fuzziness. And so he built upon that idea to have a way of tying the later with the earlier, so that the laws sort of necessarily had to give rise to beings that could make observations to congeal those very laws into existence. This all sounds pretty vague. It is pretty vague. I tried to make it less vague in that book, but it's more of an agenda. It's more saying, well, look, maybe we're sort of too stuck on this idea of immutability, and maybe we should come up with some new categories of thought. So perhaps that's a good place to say goodbye. And
yes, I just wanted to give Steve and Fuz opportunity to say goodbye and thank you, for coming to our home, ATA. And so go ahead, Steve and Fuz.
Yeah, I'll be brief. I just wanted to thank you for coming in. Like I said, you were a huge influence when I was growing up. I had no idea what a cardinal, what infinity even was, in high school. And I was starting to read books on particle physics, in high school. I did eventually join the military. I became a nuclear propulsion person, nuke. So I studied reactor physics a little bit, but I didn't make a career out of it. But I think that you and Isaac Asimov and some other prolific science writers that brought science down to a level where the average person can understand it without the jargon, without the mathematics so much, really was amazing to me. So this is a huge treat for me.
Thank you.
And Fuzzle, you want to see him off as well?
Yeah, and likewise, I just appreciate Paul, taking the time, and you're one of my favorite writers as well. I think we have different worldviews, but I love the fact that you're willing to explore the philosophical and the theological interface that, between science and other disciplines. So that to me is refreshing that you do it and treat it seriously. So thanks for being on the show.
Yes, thank you. And Hugh, do you mind sticking around for a little while?
I'll stick around, but also I just want to say my word of thanks to Paul for joining us again. It's been a real pleasure.
Been a pleasure. You've been very gracious hosts, all of you, and I hope it's not the last time we can all get together, and maybe, who knows, in the not too distant future, around a dinner table in a restaurant. Wouldn't that be nice?
Fantastic.
That would be fantastic. Archery, yes, that would be
I would be in heaven.
fantastic.
And I don't
Thank
believe
you.
it, but whatever.
Paul,
So
it's been
I will say goodbye and scurry off and talk to my
been a
students.
pleasure. Take
Okay.
care. Take care. Now, Hugh, I'd like to carry this on. And the question that Nicholas Tan asked and that Paul fielded was, is there anything other than positing a God of the gaps that compels the universe to be what it is? And what are your thoughts on that?
Well, you raise the term God of the gaps. Whenever that term comes up, I like to compare to the no God of the gaps and basically ask the question, in light of advancing scientific research, are the gaps getting bigger from a theistic perspective, or are they getting bigger from a non-theistic perspective? And I won't say a lot because I've written a lot of this, basically documenting that not only do the gaps get bigger, they get more numerous and they get more problematic as we learn more and more in the different fields of science. And so I really do think that the theistic explanation best explains the fine-tuning and why the fine-tuning evidence accumulates as we learn more and more. It's actually growing exponentially. I mean, as I read the scientific literature, every day there's some scientific research paper published that gives us yet another piece of evidence for fine-tuning.
There's another question here that I'm gonna pitch to you, Hugh, but I think Fuz will have something to say to this too, because coming from a biochemistry perspective, free to play, Bus Pays, asks the question, so the universe is supposedly fine-tuned to what exactly? And I know, Fuz, you have some ideas about fine-tuning as well, maybe from a biochemistry perspective. But Hugh, let's start with you. How would you answer that?
Yeah, I would argue that the universe is fine-tuned to make possible the existence of primitive life, plants and animals, human beings, and not just human beings, but billions of us living at one time on one cosmic body in a brief enough period of time that we can develop the technology where we can actually discover that there's a God behind all of this, a God who has a plan in place to deliver us from evil and suffering. And that, the universe is designed to make that possible in a short period of time. And as I mentioned before, I can identify at least another 10 specific purposes for why God made the universe the way he did. And in my opinion, that answers why we see in the fine-tuning design trade-offs. If you've got multiple purposes, you will have design trade-offs. And I think one of the predictive powers of the anthropic principle is that it's been predominantly cosmological. But I've written books making the point it's not just the universe, it's the supercluster galaxy. It's our galaxy group, it's our galaxy, it's our spiral arm, it's our planet, our moon, our planetary system, our star. And it's not just astrophysics, it's every single scientific discipline. And if I could give a plug, I just read Fuz's latest book, where he says, just like there's an anthropic principle operating in astronomy and physics, there's one in biochemistry. And in my opinion, it's a breakthrough book, basically making the point. This fine-tuning is ubiquitous through all the scientific disciplines. And if Fuz has got the time and can live long enough, I'm hoping he can branch out and show how this works in biophysics, physical chemistry, geochemistry, whatever Fuz has got time to do. But Fuz, I thought this really was a breakthrough book that you produce. So thank you for doing the hard work.
Yeah, and it's more of a manuscript, right? We're working towards the book, right, Fuz? Like
We
that
are,
good
yeah.
plug though. Yeah.
Yeah. God willing, and the creek doesn't rise.
Yes, good Lord willing,
and
the creek
and the
don't rise.
pandemic doesn't continue to surge. It should be available in October. But just to build off of Hugh's point, and I'd be curious to hear Steve's reaction. To me, I would go back to something that Paul Davies at the beginning of the program spent a little bit of time talking about, and that was the work of Fred Hoyle and the fine tuning of the nuclear energy levels that are necessary for the triple alpha process to produce carbon atoms, and then also subsequently oxygen atoms through, again, the collision of carbon nuclei with helium nuclei. But, because to me, that fine tuning of those nuclear energy levels essentially produces the carbon and oxygen that you have in the universe. And both chemical elements have a really unusual set of properties. And it's those unusual set of properties that make them ideally suited to support the construction of biomolecules. And so there, that fine tuning is specifically pointing to the existence of life on Earth. But and as Hughes pointed out, that fine tuning isn't just for the existence of microorganisms, but for advanced human civilization. And this is something that I know, Hugh, you've discussed in some of your writing as well. And this again was a point that Paul Davies was making an allusion to, is that it's not only that the fine tuning involves habitability, but it also involves observability and discoverability. So that the fine tuning in the universe seems to be such that human beings have this wherewithal to essentially not only observe the universe, but to make sense of the universe. But we also are located in a precise position in the universe to be able to actually see and observe the universe in such a way that we can make scientific discoveries. So to me, it's a fine tuning that makes life possible and makes human civilization possible, but also makes the universe seems to be fine tuned so that there's observers that can actually discover the fine tuning, which is, to me, mind blowing.
Yeah, that's something I've noticed that people who are not theists are stunned, is that as vast as the universe is, with 200 billion galaxies and 50 billion trillion stars, we're orbiting the one star in the entire universe where it's actually possible to explore the entire extent of the universe and its whole history. If we were anywhere else in the universe, that wouldn't be possible. And combine that with the fact that there's a unique time in which we can see the entire history of the universe. If we were placed here any later in cosmic history, we'd only be seeing a part of the history of the universe. Or if we were here any earlier, we'd only be seeing a part of the history of the universe. It really does suggest that there's a being out there that wants us to discover the cosmic creation event, to research that cosmic creation event by direct observations and discover the creator that was responsible for it. It's like there's a book out there, but we're the only place in the entire universe where that book can conceivably exist.
But going back to Leo's question there, he had asked, what did we find? What is the universe fine-tuned for? And I think that the whole point of having the fine-tuning argument is to answer the question, how are we as sentient beings able to apprehend the universe? Right? It's not the fact that we can. I mean, the weak anthropic principle is pretty accepted by people, but the fact that we're able to do it, and everything that every law of physics and everything that we have described, because again, these are not prescriptive things; they're just things we observe. There seems to be a weird consilience, almost like a supervenience from the very bottom to the very top. And Fuz has pointed out, for example, like in a nuclear reactor, if the strong secondary effects of the strong force weren't the way they were, the atom would never be able to hold itself together. If the resonant escape probabilities weren't exactly the same, if the barn ratios weren't exactly the same, if all the things that went into making our nuclear reactor, if anything was any different as far as the absorption factors, leakage factors, the mean free path, if anything had been a little bit different, we wouldn't have stable fissions to have a reactor. In fact, it's a well-established thing for a reactor that you have what's called delayed neutron precursors. These are fission fragments that exist after the fact, after the primary initial fission, that without them, you would not have stable reactor power. It just would not happen. And so there's this weird thing that all these laws of physics that we observe, we're able to utilize. And I think what the fine tuning is asking, how are we able to do that? How are we the only sentient being that we're aware of, and it is a sample size of one, but how are we able to actually not just describe these laws, but put them into practice? Because as far as we know, there's no other species or even entity in the universe at this moment that we're aware of that can do such a thing. And I think that's really what the fine-tuning argument is really trying to describe, is why. And I, Paul had mentioned about a metaphysical necessity being, some kind of explanation, and that's fine. But there are other things. It could be an infinite regress in the universe, which, again, it seems to be contrary to how we understand an actual infinity to be existing in the universe, or there could be just a brute fact, which is insufficient as far as trying to be an explanatory thing, but it could just be something we just can never understand because of biological limitations. But I'm fine with a possible metaphysical necessity being the accounting for. And I think that from the non-theist position is, does that position have to necessitate some kind of intentional agent? And I think that's the difference between where, Hugh, Fuz, and you see it differ from the non-believers, that you have determined for whatever reason that is an intentional agent, and the non-believer has not. But it's fine for them to say, yeah, there might be some kind of metaphysical necessity for why we exist that does explain why we're able to apprehend and use these laws of physics. But it could be just as well we can never understand it, right? I mean, there's no way to differentiate between the two of a brute fact or a metaphysical necessity.
I really have enjoyed learning from Steve, from you and Paul, the viewpoint. And actually, I was really kind of surprised about the acceptance and openness to metaphysical causal agent. I know he didn't like the word cause, but an origin of sorts. And then how much agreement there actually was. And of course, through the Christian lens, to us, it's as clear as cut and dry. We have a name. It's in the Bible. There's a story of Paul walking through a town, and they have all of these statues of gods, and there's specific gods, and there's one, the unknown God, and he's like, okay, I want to tell you. He's like, I happen to know this unknown God. And so I'm not saying that's where we should land, because we try to keep this an even playing field, but that's what it feels like from our perspective, that we are just so much on the same page about so many things, and just kind of coming to a different conclusion that it doesn't necessitate that it has to be the God of the Bible, and the other side saying it has all of the earmarks, the attributes of the God of the Bible. And with that, we have to wrap it up. Believe it or not, this time has blown by us, and it's been such a good conversation.
Can I just say one thing though, Sia? The thing I've noticed when I've engaged scientists who are not theists is that they'll look at the fine tuning and say there's no connection whatsoever with purpose. So I think that's really the core of where we can go forward. Does the fine tuning really indicate purpose and personality, or is there no connection whatsoever?
Yeah, and Steve, you look poised.
I was going to say, it does seem to be about some kind of between some kind of Christian or a God with intentionality and Spinoza's God, right? I mean, one could actually just appeal to a God of the philosophers, which obviously doesn't have intentionality, but both have their explanatory power and both have their non-explanatory power.
Exactly. And there is a word that has been used by nearly everyone here today, including Paul, that I love, and it's mystery. And I just find that beautiful, lending ourselves to the mystery. And we would call that unknown God, we would call that mystery the God of the Bible. With that, I would like to thank you, Hugh, so much for coming on. This has been a great conversation. Again, I want to thank Paul, even though he's not here, for both of you. It was great engagement. And Fuz, thank you for what you brought to the table, kind of from a biochemist standpoint too, and the fine tuning that is unexpected that we see there. And of course, Steve, your philosophy, but you're fanboying too. I have to admit that was just plain old fun.
I think we all were fanboying a little bit.
Yeah. Well, I mean, when somebody has a huge impact on your life, because like I said, I was sort of reading for real. I mean, his theory on time travel and black holes, I mean, he's across the board, somebody who just knows a lot about a lot of topics. You don't find a lot of people like that often. He's just amazing, the things he can write about and popularize it too, and put it in a way that the average person can understand and go, wow, I'm amazed by this.
Yeah, and it's equation free.
Yeah, because math is hard.
Because math is hard, and we just, and that's just the people that we have, whether it's our viewers or our guests or our hosts. We just have some people that really change your life, and I'm so appreciative for that. And with that, I'd like to say goodnight to everybody and say that I look forward to seeing you again in the future. And when we do, remember to bring your challenges, your curiosity, and your sense of humor when we come again together on Agree to Argue. Goodbye.